Unit 10 is called Triangle Trigonometry. And you might say, well, we've been doing trigonometry. I've heard Ms. Allensworth talk about that. Yes, triangle trigonometry is just the study of triangles, finding missing things. But this gets a little farther in depth of something you probably have never seen. And it's this SOHCAHTOA. And what these are, this is an acronym. An acronym is like FBI or FCA or whatever letters that stand for words. So it helps you remember it. And these are to help us identify trig ratios. So right now there's 3 trig ratios you need to know. This is called sine. I know it looks like sin, but it's actually S-I-N-E. This is just the abbreviation. There's sine. There's cosine, C-O-S-I-N-E. And then tangent, T-A-N-G-E-N-T. So there's 3 trig ratios you need to know. Sine is the SO part of this acronym. SO stands for sine is opposite over hypotenuse, OH. Cosine is the CA, the C-A-H, that's cosine is then adjacent over hypotenuse. And then TOA stands for tangent is opposite over adjacent. And these are going to be sides from a triangle. When you see this little symbol here, this is a Greek symbol called theta. T-H-E-T-A, that just is an angle. So it's saying sine of this angle is this ratio or this fraction of the triangle's sides. It's really a simple concept once you get past just the weirdness of the new words. So number 1, we have a right triangle here, and we've got a leg of 21, 28, and 35. See how all of these say sine of A, cosine of A, tangent of A? This is our angle that we want to look from. So I always tell kids, imagine that you're literally standing here in angle A, looking out. Maybe with a bow or something, like you're aiming. Across from angle A is the 21. That's your opposite side. And then pick out the hypotenuse. That's always across from the 90. And so this leg right here is the adjacent leg. So here's adjacent because it's touching the angle. Here's hypotenuse is always hypotenuse. This is opposite across from it. So when I say sine of angle A, sine, think SO, opposite over hypotenuse. So the opposite side is 21. The hypotenuse in this triangle is 35. And then you just need to simplify if you can. So we're going to divide by 7. That would be 3 to 5, 3/5. Right now we're going cosine to angle A. Still standing here in this corner looking out, but this time cosine is CA, C-A-H. So it's going to be adjacent over hypotenuse. The adjacent side to this was the 28. And then the hypotenuse is the 35. And then divide by 7 again to simplify. That would be 4/5. And then last one is tangent of angle A. Still standing here. Tangent is TOA, opposite over adjacent. So we want opposite side, 21. 28 is the adjacent. So 21 over 28, divide by 7 again. That would be 3/4. So all you're doing is coming up with a fraction or a ratio. Let's try number 2. If you'll notice, it's the exact same triangle. I just copied and pasted, but now we're looking from angle C. So you want to imagine that you're standing here in angle C looking out. So now the sides change. This is your opposite side. This is still your hypotenuse, but now this 21 is the adjacent because it's literally touching angle C. So sine is going to be opposite side over hypotenuse. That would be your 28 over 35. And we actually saw it right here. That would be a 4 to 5. Cosine of C, that's your CA, adjacent to hypotenuse, that would be 21 over 35. Divide by 7, that would be your 3/5. So you'll notice that these two things just swapped because now you're looking from a different angle. Tangent of C is opposite over adjacent. So that would be your 28 over 21, which is just the reciprocal of this and flip. So now it would be a 4 to 3 ratio. Okay, let's try a couple more. Number 3 says find the value of cosine of n. So again, this is your angle you're looking for. This is the order the ratio needs to go in. So cosine is CA. You could write like this too. So you know that it's a fraction. So from n, I need adjacent, which would be this one, over hypotenuse. I'm not using the opposite, but problem, I don't know what the adjacent leg is, so I'm going to have to do Pythagorean theorem to figure that out. So it'd be square root of 21 squared plus x squared equals square root of 85 squared. Square root cancel. Subtract the 21, so that would be 64, and square root that makes this 8. So now for cosine of angle N, that would be adjacent is 8 over square root of 85. I should have wrote smaller because now I got to fix it by rationalizing. Oh, nearest hundredth. Nearest hundredth. So actually we're just going to do it on a calculator. 8 divided by square root 85. So that'd be 0.87. Okay, number 4. Find the value of sine, don't say sin, sine of angle R. So we're looking from here. Sine is the opposite over hypotenuse. Opposite over hypotenuse. So opposite is always looking straight out across from you. Hypotenuse is here. So it'd be square root of 20 over 6. But square root of 20 can simplify into a square root of 4 and a square root of 5. So that'd be 2 square roots of 5 over 6, and then your 2 6 can simplify down to a third. So square root of 5 over 3. And it wants it in a radical. And then last one is the same stuff, it just does not have a triangle. I would make one. You also know that it's a right triangle because it says that angle I is 90. And it does not matter which one you call G and which one's H. So GI is 84, IH is 13, HG is 85. What is the ratio to represent tangent of angle G? So tangent is the TOA. Opposite over adjacent. Opposite would be the 13 side. Adjacent would be the 84. I don't think 84 divides by 13, does it? No. So we should be able to just leave it like that.